So today we are going to solve one of the latest question of for the math. It is from paper 4-2, which has come in October November 2025. So the question is about a continuous random variable x, which has cumulative distribution function f given by this one. Okay, so we have a cumulative function here, and in the very first question we have to find the values of a and b. Okay, so let's do it. So for that, first of all we need to know that cumulative function is like a staircase. Like it start from here and goes down here. Like the topmost part gives us the maximum value, that is 1. Okay, so we'll take that logic and try to solve it. So for example, the maximum domain that it could have, like the range of value is 6. So if we plug 6 in this equation, it must give us value 1. So let's do that. So f of 6, or you could say probability 6, f of 6 is and also if you find the probability in CDF, it is always less than equals to a. If something I'm seeing f of 6, that is x is less than equals to 6, so it is all, so that would be 1. So therefore we can plug 1 over 5 into 6 square plus b equals to 1. And if you calculate the I guess that is 50 here, so that will be 36 over 50 plus b equals to 1. So if you take this one here, that would be like 36 over 50, that would be 14 over 50, that would be 7 over 25. Okay, so we have got the value of b here, that is 7 over 25. Okay, and now let's calculate the value for a. So for value of a, what we could do is the value of 4, if we plug here in this one, it will give the same value as if you plug 4 in this one. So you could use that fact to solve this. So let's do that. So f of 4 equals to f of 4. So first plug 4 in the first function, that would be 1 over 5 into 4 plus a equals to 1 over 50 into 4 whole square plus b. So b value we already have calculated here, that is 7 over 25. So let's use the fact that 7 over 25. So that would be 4 over 5 plus a equals to 16 over 50 plus 7 over 25. So if you work it out, it will give you a equals to minus 1 over 5. Okay, and for the next question, let's just jump into that. So I have copied the question number b here. In this question we need to find the probability density function, that is PDF. So for that we already have a CDF here, and for that we have to use the fact that derivative of CDF equals to PDF, that is our probability density function. So let's use the fact. Okay, so since it is like a piecewise function, we have to do on the basis of that. So let's use this one first. So we have already found the value of a here. So if let's use the x 4, so then we have to derive that function, that is 1 over 5 x plus, okay, that is minus here 1 over 5 a value equals to 1 over 5, right? And if you derive this one, b is the constant value, it will go out. And if you derive this one, like here, for other domain, that is for this domain, we could use derivative of that, and that would be equals to 1 over 50 x square plus 7 over 25, constant value would be 0, so that would be 4 okay, my bad. That would be 2x times 1 over 50. That would come out as 1 over 25x. And let me present the our PDF here. That is, f of x is equals to 1 over 5 in this domain. Okay, so let me write it out. 1 over 5 if 1 x is between 1 and 4, and for this domain we have 1 over 25x. So 1 over 25 x between 4 and 6, or 0 otherwise. So that is the answer. And now let me jump into the next question. So in the next question we have to find variance of x. I have already copied the PDF and CDF here for like we need it in our next question, so that's why. So we have like the expectation is here, we need to find the variance, and for variance we have the formula that variance x is equals to, we need to integrate it, so x square f of x, that is PDF. Okay, so we have to integrate PDF, and that is we have like range, right? So I will not write range here, I'm just writing a formula first of all. So we already have that is the ex, so we need only to calculate this and then subtract it from this. So let's calculate this one. So first of all, let's integrate the first part of the PDF function, that is 1 over 5, and the our lower limit is 1, upper limit is 4, and that would be x square dx. Then we have to integrate this one as well, so 1 over 25, since it is a constant term it will be out, and lower upper limit would be same, x square multiply with x dx. Then we have to subtract 529 by 150, that would be whole square. Let's do it. That would be 1 over 5 x cube over, say, that would be 4 over 1 over 25, and that would be our x cube. Okay, that already had been x cube, so we need to, that power would be x4 by 4, that would be from 4 to 6. And let me use my calculator to get the value. So if you carry out this, that would be 73 over 5 minus this one, that would be like 12.43, and that will be approximately equal to 2.16. That is the answer for this one. And there is one last question, let's see it. So I have copied the last question, so it's about percentile. So we already have like series, which is easier to find percentile compared to PDF, because in PDF we have to like integrate, but since we already have like a CDF, let's use this one to calculate percentile. So let's do it. So we have to find the 10th percentile. So the probability of 10th percentile is 0.1. Okay, and the probability of 90th percentile is 0.9. Okay, so first check it out like in our CDF. Let me copy that CDF part here so that it would be easy. I will only copy the two thing, that is 1 over 5 x minus 1 over 5 and 1 over 50 x square plus 7 over 25. So, and we also, let me copy the range. Okay, so 4x. Okay, so we have to say if the 10th percentile lies in this or not. For that, use the extreme value. Let's put 4 in this, and if let's see if it is greater than 0.1 or not. If it is greater than 0.1, then 10th percentile must lies in this one. Okay, so I have my calculator, so let me do that. 1/5 into 4 minus 1/5, so that's come out to be 0.6. so if you put 4 here, that is the extreme value, so f4 gave us 0.6. so it is stating that up to 60 percentile value lies here in this one, and 60 percentile value is given by 4. Okay, so let's do that. So 10 percentile must lies in this one, and 90 percentile must lies in this, since it is less than 90 percentile. So okay, so I will use the first one. Let me put for 10 percentile, let's use t here as a dummy variable. So 1/5 t minus 1/5, so that would be 0.1, since the probability is 0.1 for that. So 1/5 t minus 1/5, that would be 0. If you take this one out here and add, that will 0.3 1/5 t, and t value comes out to be 0.15. oh okay, my bad, 1.5, and that is the answer for this one. Let's find the 90 percentile. So for that we should use this one. We have to plug in this one, so let's use variable p for that. So that will be 1/50 p square plus 7/25, and the probability would be 0.9, and 1/50 p square plus 7/25, that would be, if you take it out here, 7/25 is around 0.28. So and here it would be 1/50 p square. Sorry about the background noise. So 0.9 minus 0.28. Okay, let me calculate this one as well. When we multiply it by 50, we'll get 31 equals to p square. So for p, its value would be root under 31. So we will only take the positive value, because negative value is not within this range, since all the values are positive. So that is our answer. So if you like my concept and if you find it helpful, please like the video, comment below which solution you want, and see you in the next video.